SkexGen, autoregressive generation of CAD construction sequences with disentangled codebooks. Computer-aided design is important for 3D content creation. It enables the development, modification, and optimization of the design process. Professionals often need to generate diverse CAD models following a design intent. This is traditionally done in parametric CAD models with manually labeled constraints. However, too much constraints lead to limited diversity, too little constraints lead to failures during design exploration. SkexGen solves the issue by using disentangled codebooks to capture the topological and geometrical variations. It can generate diverse results and enable efficient exploration of the design space. Our input data is sketch and extrude construction sequence, which consists of 2D sketches that are extruded into 3D solids. More precisely, we represent sketch and extrude as a sequence of primitives. The most basic primitive are curves. Topology token indicates the curve type, which can be line, arc, or circle. Geometry tokens consist of 2D coordinates which describe the curve shape. End primitive token indicates the end of a primitive, in this case the end of a curve, which is an arc. Multiple curves are connected, and a closed path is referred to as the loop. Multiple loops can be combined to form a face. And finally, multiple faces are combined to form a sketch. Every sketch is paired with extrude tokens which describe the extrusion parameters such as translation and extruded height. A sketch is then extruded into a 3D solid. Multiple solids are combined into the final CAD model by Boolean operation. Now we will go over the SkexGen architecture. Given the primitive sequence as input, topology tokens are passed to topology encoder, geometry tokens are passed to geometry encoder, and extrude tokens are passed to the extrude encoder. Following region transformer, input sequence is encoded into special code tokens, which are then passed to the codebook for quantization and code selections. The selected codes are concatenated and injected as cross-attention to the sketch decoder, which autoregressively predicts the next token. The sketch branch has 3 loss functions, 2 codebook losses, and a token reconstruction loss. Extrude branch is similar to the sketch branch. Please refer to our paper for more details. Finally, the sketch and extrude tokens are merged and passed to a standard CAD software for parsing it into the 3D CAD model. During generation, we need to first sample the code and then sample the sketch and extrude tokens. Here we demonstrate a conditional generation case where the topology code is given, and we need to first find the most compatible geometry and extrude codes and then generate the tokens. A code selector autoregressively generates the next codebook index based on the code prior. The generated codes are then passed to SkexGen decoders for token generation. The decoders are also autoregressive and sample based on the learned probability. Here we demonstrate an example where conditionally generated models share the same topology as the input. SkexGen can randomly generate diverse and high-quality CAD models. Performance on standard evaluation matrix also surpassed DeepCAD, the previous state-of-the-art for sketch and extrude generation. It can also be used to generate CAD engineering drawings, achieving much lower FID score than previous methods. By using the conditional code selector, SkexGen supports conditional generation from a given design intent, which in our case is represented as having the same code. For instance, one can generate shapes with similar topology, similar geometry, or even similar extrusion. SkexGen also supports efficient design exploration where code from different models are mixed to create a new one. In this example, the generated CAD consists of multiple cylinders as in the topology model, but the layout and extruded height follow that of the geometry and extrude models. One could also preserve the topology and geometry features, but extrude it in a different direction. Finally, one can transform a happy face into a not-so-happy one. 2 circles and 1 rectangle come from the topology model, and layout from the geometry model arrange them into the eyes and the mouth. It is also possible to generate intermediate models by performing code latent interpolation. Leftmost column is the source and rightmost column is the target shape. Topology, geometry, and extrude codes are interpolated together. Please refer to our paper for more results. Thank you.